All right, let's dive into the world of competitive programming. Consider this your fast-paced boot camp. We're going to get you geared up with the absolute essentials, the skills, the tricks, the insider info, to get you ready for your first real contest. Let's jump right in.
First things first, you've got to understand the arena. Every single problem is really two challenges rolled into one. On one hand, you have the mind game, which is all about algorithm design. Can you be clever? Can you think through the math and come up with a solution that's both correct and super efficient? But then there's the code battle. Can you actually take that brilliant idea and turn it into clean, working code that passes all the tests before time runs out? See, a genius algorithm that's coded too slowly is a fail, and super fast code with a flawed algorithm also a fail. You absolutely have to master both to win.
So here's our game plan for today. We'll start by scouting the arena and picking our language. Then we'll build out your personal C++ starter kit. After that, we'll tackle the tricky business of working with numbers, learn some pro-level coding habits, and wrap up by showing you exactly where to go to find the community and start competing.
Okay, let's get into it. Section 1, the competitive programming arena. And the very first decision you have to make before you even think about a problem is choosing your weapon, your programming language. And believe me, this choice really matters.
Just take a look at the data from a huge contest like the Google Code Jam. The numbers tell a pretty clear story, don't they? C++ isn't just popular, it's completely dominant. We're talking a staggering 79% of competitors. Sure, Python and Java are there, but C++ is the undisputed king of the hill. So, what's the big deal? Why C++?
Well, it really boils down to three huge advantages. First, speed, and I mean raw, blistering speed. When a problem has a 1-second time limit, C++'s efficiency is a massive leg up. Second, it comes with a built-in treasure chest called the standard library, which is just packed with all the tools you need, data structures, algorithms, you name it. And finally, it's basically everywhere. You can be confident that no matter what contest you enter, C++ will be an option.
Okay, language chosen. Now let's build out your starter kit. This is the code you'll begin every single problem with. Think of it as your pre-flight checklist, the foundation for everything you're about to build.
So what is all this stuff? That first line, #include bits/stdcp++.h, is a bit of a contest-specific magic trick. It just includes the entire standard library at once, so you never have to waste time remembering individual headers. The second line, using namespace std, is a simple time saver. It lets you write things like count instead of std count. It's all about eliminating extra keystrokes.
Now, I'm going to let you in on your first real secret weapon. These two lines of code right here, they're a game changer. They turbocharge C++'s input and output. For problems with a ton of data, this can literally be the difference between a time limit exceeded error and a correct answer. And here's a crucial pro tip. Always use /cn for a new line, not endel. Endel does an extra operation called a flush, which slows things down just enough to be a problem in a tight race.
You basically have two options for your I/O. The modern sin and count are way easier and more flexible. The old-school scanf and printf can be a hair faster, but they're also way more finicky and easier to mess up. Honestly, with the speed-up trick we just learned, sin and count are the perfect balance of speed and convenience. Just stick with those.
All right, next section, and I need you to pay close attention here because this is probably the single biggest area where beginners get tripped up. We're talking about working with numbers and the nasty hidden traps that can ruin a perfectly good algorithm.
Okay, quick pop quiz. Take a look at this code. We've got an integer, a, we're squaring it, and we're storing the result in a long, which is a data type specifically made for huge numbers. So the result should be correct, right? It should be well over 15 billion. Seems simple enough? And nope, the result is this massive, weird negative number. What happened? This isn't a compiler bug. This is a classic logic trap. It's called integer overflow, and it has probably knocked more beginners out of contests than any other single mistake.
So let's break it down. Why did that fail? We used a long variable for the result, which is definitely big enough to hold the answer. So what went wrong here?
Here's the sneaky part. C++ evaluates the right side of the equation first. Since a is an int, it does the multiplication a times a using 32-bit math. The number gets too big for 32 bits, it overflows and becomes garbage, and then that garbage value gets stored in your 64-bit long. The damage is already done. The fix is to tell C++, hey, treat a as a long before you do the math. That little long cast forces the entire calculation to happen in 64-bit space, and just like that, the overflow is prevented. So, typecasting is your go-to for many overflow issues. But what if the numbers are so ridiculously huge they won't even fit in a long? That's where modular arithmetic comes in. If you ever see a problem, ask for the answer modulo m, that's a giant flashing sign. It's a hint. It means you don't need the exact massive number. You can use this magic property to take the remainder after every single calculation, which keeps all your numbers small and completely sidesteps the overflow problem.
Okay, we've secured our logic against number traps. Now let's talk about a different kind of speed, your physical coding speed. Every second and every keystroke counts in a contest, so let's look at how the pros write code faster.
Let's be honest, typing long, or vector int a bunch of times is just tedious and slow. So a super common trick is to use typedef to create short aliases. Long becomes LL. Vector int becomes VI. It might seem like a tiny thing, but when you're writing code under pressure, this saves a surprising amount of time and mental energy. Want to take it up another notch? Meet macros. Using #define, you can create short abbreviations for common functions. So that long, clunky pushback becomes just PB. Make pair becomes MP. Just look at the difference. The code on the right does the exact same thing, but it's so much quicker and cleaner to type out.
But a word of warning. Macros are powerful, but they are also kind of dumb. They do a literal copy and paste of your text. So if you define a square macro like the one on the left and call it with SQ3+3, you're not going to get 36, you're going to get 15, because it expands to 3 plus 3 times 3 plus 3. The solution is to get into the habit of always wrapping your macro arguments and the entire macro itself in parentheses. It's a crucial defensive move that will save you from some very confusing bugs.
All right, last section. You've got your tools, you know the techniques, so where do you actually go to do this stuff? You can't improve in a vacuum. You've got to join the community and start practicing. Now, at the very peak of the sport, you have the major leagues. For high schoolers, the pinnacle is the IOIO, the International Olympiad in Informatics. For university students, it's the ICPC. These are basically the world championships, the ultimate goal for competitors around the globe.
But you don't start at the World Championships. Your day-to-day training happens online. Websites like Codeforces, AtCoder, TopCoder, these are your gyms. They host contests all the time, often multiple times a week. This is where you go to solve problems, compete with others, and really truly sharpen your skills.
So let's quickly recap our boot camp. 1. Remember the 2 pillars, algorithm design and implementation. You need both. 2. Build and master your C++ toolkit, especially those I/O optimizations. 3. Always be on the lookout for number traps like overflow. And 4. Use shortcuts like typedef and macros carefully to write code faster.
And that's it. You now have the fundamental toolkit. You know the language, you have the template, you're aware of the common pitfalls, and you know where to find the arena. All the theory is in place. The only thing left is to start solving. Your first problem is out there. So, are you ready to compete?